Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 63 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Raphael kit for Raspberry Pi. Now, most of you guys probably already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And we have a really exciting lesson today. And what I'm going to teach you is I'm going to teach you how to do object detection on the Raspberry Pi using Tensorflow Lite. Okay, so we're going to do object detection. Now, this is a continuation of the theme that we've had for the last 6 or 7 lessons, where we've been looking into artificial intelligence on the Raspberry Pi. Now, we started by learning the basics of OpenCV, how to use the camera. Then we started learning how to track an object based on the object's color. Then we learned how to identify and track faces in your field of view coming from your camera. And now we're going to take it to the next level where we're going to go in and be able to identify objects in the field of view of the camera. What do we mean by that? We mean that it's going to look at a frame, it's going to find the objects that it recognizes, it's going to draw a box around them, and it's going to label them. How cool is that? I think it is just pretty neat, and I hope you enjoy this lesson because I've had a lot of fun playing around with this the last few days, and actually I've been pretty impressed with the performance I was able to get out of my Raspberry Pi 4. So yes, I am using a Raspberry Pi 4. If you're using a Raspberry Pi 3, your frame rates are probably going to be a little bit less. Now, very important for this lesson, and I gave you this as a homework assignment in last week's lesson, you need to start with a fresh SD card. If you like your old SD card, you can keep your old SD card, but take it out and flash a fresh SD card, because for this to work smoothly for you, we need to be on identical versions of the software. So what you need to do is you need to get the 64-bit version of Bullseye. Okay, the 64-bit version of Bullseye on a fresh card. Why a fresh card if you already have 64-bit Bullseye? I have no idea what kind of nonsense you've put on that card and what versions of software you've already put on there. So if you start with a fresh card and I start with a fresh card, you will get the same results that I get. If you start with a different card on a different version with different stuff on it, you might not get exactly the same results that I get. Okay, so if you want to get exactly what I get, you need to do things exactly the way that I do them. Okay, so enough of this talking. What we're going to do is I've got a fresh Raspberry Pi card all ready to go here, booted up and ready to get going. Now, the first thing that we're going to need to do is we're going to need to go in and install Tensorflow Lite. Okay, and it's actually not that hard to do. I will probably make you happy if I get out of your way so you can see things a little better. And there's just a couple of things we need to do to get this going. And within a few minutes, we'll actually be up and coding. Okay, but we need to start by opening a terminal. Let me take a second here and see if I can get you this is a fresh card. And what you need is you need a larger font on this. Man, I told you guys it was a fresh card. So don't be surprised if some things aren't exactly the way we want them as we go through it. Okay, there it is. I think you will be able to watch me pretty easily now. And so I'm going to start by saying sudo apt-get update. Okay, this can go fast or slow depending on how long it's been since you have done an update. This is a fresh card, so there's not too much stuff to worry about here. And now I'm going to do a sudo apt get upgrade. So we're going to upgrade all of those things. And even though this is a fresh card, sometimes it takes a little while. This actually went pretty fast. And so now we have a fresh card, and it is all updated and it is all upgraded, and we are ready to roll here. Now I'm going to go ahead and make a directory, mkdir. And let's look at what's in this home directory right now. So I'll just do an ls, and you can see we've got the standard set of starting folders. So I'm going to go ahead and do a make directory of Python. And since they uppercase the first letter of their directories, I'm going to uppercase the first letter of my directory. So I'm going to have Python. I'm going to go on and cd into Python like that. Okay, ls, it's empty as you would expect. Now let's make a folder to do this TensorLite work in. So I'm going to do an mkdir, and I'm just going to say tLite like that for TensorLite. Okay, now let's change directory into tLite. Okay, and now what we are going to do is we're going to go out and we're going to download those tensor libraries and all that tensor software that we need. And we will do that from GitHub. And so let me make sure that you can see this line, because this line of code is going to be this command is going to be a little bit longer, and I want to make sure that you can see it. So let's get our window all up in a clearly easy to see place. Okay, now we're going to do a git clone and HTTPS. The S is kind of important. Git clone HTTPS and then / github.com, and then we are going to Tensorflow, and we are going to / as much as I didn't want my head to cover that, my head is covering that. Okay, now you can see it. Git clone https / github.com / tensorflow / examples, and then a space, and then a dash and then DEPTH space 1. And that would probably be good if that was all on one line. Okay, so it's examples space -- depth 1, and let's hope this thing finds everything. And so now if I come here, I should just be able to press enter and hope we see it says cloning. At least it didn't yell at me. It looks like it's getting stuff. This is kind of exciting. I think this doesn't take very long, and so don't get too worked up about this. I'm not going to pause the video or anything. I'll just sit here and chat with you as this downloads, as you're probably having to do this too. It's not going real fast. Maybe my internet connection is a little bit slow here this morning, but we'll just wait here and we'll let it download. Okay, but I am really excited about this. I've been playing around, and it's TensorFlow on the Raspberry Pi. It's a pretty cool thing to do. And we are up to 76% and almost there. Almost there. Okay, now, okay, boom. We're all done now. Okay, so now we need to kind of navigate to a specific place, and rather than give you a cd something / something / something / something / something, that's kind of hard, because if you make a mistake in there, then you got to go all the way back. So we're going to do it one at a time. Let's ls, and now we're going to change directory into examples like that, ls. And now we're going to change directory into Lite, because we are using TensorFlow Lite. Okay, we're going to ls, and now we're going to change directory into examples. So this is like examples inside of Lite, inside of examples. And then we're going to ls again. And now what we see is we want to go to object detection. So I'm going to ls, and then I'm just going to put ob. And here's a pro tip: if you click tab at this point, it fills out the rest for you, because that was the only thing that started with OB. Somebody told me that about 6 months ago. I thought, man, If I would have known that 10 years ago, the last 10 years of my life would have been a whole lot easier, not having to type in these long things. Okay, now we're going to change directory. Oh, wait a minute, I LS'd into object detection where I should have, let me see. Yeah, I should have changed directory into object detection like that. Okay, now I'm in object detection, now I LS. Now we want to go into Raspberry Pi, so change directory rasp. And now I click tab and it takes me to Raspberry Pi. Now LS. Okay, here we are. All right, here we are. And here's where the action happens. Do you see this sh file, setup.sh? We're going to run that. So we're going to say sh, and then we are going to say setup.sh. And man, it's like no matter what I do, this path gets longer and longer and longer, and I hate having it go to a different line. So sh space setup.sh, and we are going to run that thing and see what happens. Okay, it is sitting there. Okay, so it's doing some installations, and it says it already has pip, so it's not well, it does look like it's collecting pip, so it's gonna install the different things we need to run TensorLite. And the nice thing about this is we are not having to go in and type in 20 different commands. This is just a script, and it does everything that you need in order to get TensorLite working. Okay, I think now I'm going to probably make this bigger and come down, and it takes 2 or 3 minutes for this to go, but I think again we'll just sit and wait on the download together. But like I say, I was happy to learn that it's relatively easy to get TensorLite installed, and we're going to have our first program written today. So sort of like by the time this lesson is over, you will be doing object detection along with me. It's going pretty fast. So yeah, I really like using separate SD cards when you're really going into a specialized area like this. Similarly, if we do media pipe in the future, I'm going to recommend that you have a media pipe SD card, you have an SD card for TensorFlow. Okay, this is moving right along. Okay. It's giving me some warnings. Now, when I did this earlier, everything worked. Okay, so I didn't really have to worry about those warnings, but I'm trying to look at that. Okay, it didn't. Those warnings didn't cause me any problems. Okay, so it looks like that is all good. Okay, that is all good. Now what we need to do is we need to ls, and we need to kind of see what we have here. All right, now this is the thing. This is the thing. We are going to need this model. This is the TensorFlow Lite model that understands how to look for objects. We're going to need that, and we're going to need this utils.py. Okay, and those two files have to be in the same folder that our main Python program is. So we could either, every time we played with this, navigate down to this folder, or we could take these two files and put them in our main Python folder. And that's what I'm going to do, because if you come back in 3 months, you're going to forget where all this stuff was. And so what I'm going to do is I'm going to do a MV for move, and then I'm going to move EFF, and then who's your friend, Mr. Tab, and that goes to 0, because you can see that there's two files that start like that. So to tell it it's this second one, I'm going to tell it a period there, and then I'm going to tab again. Now I've got the same thing, and where do I want to move that? I want to move that to my home folder, the squiggle, and then slash Python, that folder that we just created. And if you've done things exactly like me, your folder should be there, and then when you click this, voila, it worked. Now what we also want to move is we want to move the utils.py, and we want to put that in squiggle. That's my home Python. Okay, and now ls, All right, now change directory to home, ls, change directory to Python. Okay, ls, and there I've got those things that I need. I've got the utils.py and I've got the model. Okay, sometimes guys get mad at me for moving through my directories one at a time, but I just find it easier to follow along when it's done that way. Okay, now what we're going to need to do is we are going to need to open up Thonny. Okay, we've got Thonny opened up, so I'm going to come and I am going to say new. And then what I'm going to do is I'm going to go ahead and save this because we've got to make sure that we save it in the right spot. And so we are going to go to this Python folder that we created, and then there is our utils.py. The other one doesn't show because it's doesn't have the suffix.py, and so that's okay. So what we're going to do is we're going to call this detect.py. In the .py is kind of important, and so we're going to do that. Okay, now we're going to jump in and we are going to start coding here. So I'm going to start by saying import CV2, because you can imagine we are going to need to use OpenCV. We're going to import time because we're going to want to be doing the frames per second, and then we're going to want to use the Pi camera. Now when I write this program, I'm going to set it up where you can use the Pi camera or you can use a webcam, so you can switch back and forth between your cameras. So then we're going to say from Pi camera 2, we're going to import Pi camera 2, and be careful of case. The first Pi camera all lowercase, the second one, the P is uppercase. Now we need to get those tensor libraries that we just installed. So we're going to say from tflite_support.task, we are going to import the core library. Okay, the core library. Now these are very similar libraries here, so I'm going to go ahead and copy this, Control C, and then Control V, and then Control V. And so from tflite-support task we get core, and then we need processor, and then we are going to need vision, like that. Those are all good. And then we need to import utils, and that was that file that we moved into this folder. Let's just make sure we can import these things. So I'm going to run this and just see if we have a problem. Okay. Oh, tflite-support. Did I misspell something? Task. Task. That is the danger of copying and pasting. It was task. Okay, so now let's run it. But also, that's why I like to run it as we go. Okay, so that all works. You see down here, let me make sure that you can see this good. Okay, that looks a lot better, and you can see the terminal window down here, so you can see what's happening as we go along. Okay, now this you got to kind of type in carefully. So we got to tell it what model we're using, and the model we're using is efficient det underscore lite 0 dot tflite. Like that, tflite. So get this exactly right, efficient det underscore lite 0 dot tf for TensorFlow Lite. That is the model in the string, and enter. Okay, now we've got to put in some parameters, and one is the number of threads, num threads, and this is like how many threads is TensorFlow going to run to try to find objects. So it's kind of like doing threading down in those libraries, and I'm just going to put 4. That seems to work pretty well for me. You can kind of play around with it and see what you want to do. Now we got to go ahead and tell it what size we want to do this at. So I'm going to say display width is 1280 pixels and display height is equal to 720. Now this might be too big, and if it runs really slow, we can make it smaller in order to get it to run faster, if that makes sense. Okay, so now what we're going to do is we're going to come in and set the camera up. So I'm going to say PyCam2 is equal to PyCamera2. Okay, this should make sense if you've taken my other lessons. And then what I'm going to do is PyCam2.preview and then preview PyCam2 preview underscore configuration dot main dot size. And this is telling the camera that we want the size to be display W, comma, display height, which we just set up. Okay, so that's preview underscore configuration dot main dot size and display with display height. Now we're going to come in and say PyCam2, okay, and then we are going to do dot preview again, and then we are going to do underscore configuration, and we are going to do main dot format, and that is going to be equal to the string uppercase R G B 888. So 8-bit red, green, and blue is going to be the format of our image. And now we're going to do PyCam2.preview and underscore configuration.align. And this just says if we ask for a size that isn't a standard size, adjust what we ask for to something that is a standard size. And that way, if we make a little mistake in putting a size in, it will adapt and still run pretty good. Okay, now I'm going to do PyCam2.configure. And how are we going to configure it? With the preview that we just set up, PREVIEW. So we just set all that up, and now we're going to say to use that, close your parentheses, so we configure it to the preview. Now let's start the camera, PyCam2.start, like that, open, close. Okay, now the Raspberry Pi camera is set up and ready to use. Now let's set up the webcam. So I'm going to say the webcam is equal to, for me, it is open string /dev /video 2. Okay, now how would you figure out what yours is? Let's come here, and what you would do is you would, give me just a second here, you would do the command v4 L2-ctl and then -- and list devices. This will show you your camera devices if I typed it in right. Okay, now here they are, and it's kind of strange the way this does this. On the updated and upgraded Bullseye, it gives us like a whole bunch of different paths to the same video, but these up here, I'm not exactly sure. These might be like the Raspberry Pi camera. Well, this one certainly is the Raspberry Pi camera here on video 0 and video 1. And then here, this one you can see the the C270 HD webcam is the one that I have. Yours is going to be different, but you want to look for the thing that says webcam, and then you can see my webcam is at video 2, video 3, and media 5. Now I haven't tried to see if I put in video 3 if it still works or not, but it works for me with the first one, video 2. Okay, so that's pretty good. So you can see how I got that. So you can kind of figure out what webcam you are on. And now we need to set up that webcam. And the way we are going to set up that webcam is, we are going to do a cam is equal to cv2.video capture, video capture from what? The webcam that we just defined. Okay, now we've got to set it up. So I'm going to say cam.set and then cv2, okay, dot cap prop and then frame and then underscore width. And then what do we want that to be? Well, we want it to be display width that we define above. Okay, these next couple are almost the same, so I'm going to copy that and paste, and I hope I'm not pasting mistakes again, but we're going to have cap prop frame height as well, like that, and then that is going to be display height, and we need to set the frames per second, so cap prop in here, you just take that and say FPS for frames per second, and we're going to set that to 30 frames per second. Okay, so now we have that camera set up. We've got both cameras set up now, and even though we haven't done anything, I'm going to run it just to see if I've got any errors in there in those things that I did. Okay, display height is not defined. Yeah, okay, what is that? Display height is defined. I misspelled it down here in line 17. So display height, like that. Now let's see if it runs. Okay, you can see that we get some errors, that the camera manager is doing this. It's like a warning. It says there's a mismatch between Unicam and Cam Helper. And man, I tried to get to the bottom of that, but it doesn't seem to be that there's any problems, but it just gives you that warning. And so after playing around with it a few hours, I decided to ignore the warning. Okay, so now we have the two cameras set up. So now let's get some other things ready to go here. And so what I am going to do is I am going to come down here, and I got to set up, we're going to calculate the frames per second, and so I got to tell it when we display it, where do I want to put it? Well, I want to put it over by about 20 pixels, and then I want to put it down about 60 pixels. So that would be the upper left. That's just going to be the position of the label, and so I'm going to say position is equal to that tuple. Okay, now I need to set up a font. So I'm going to say the font is equal to cv2.font underscore Hershey underscore simplex, like that. Okay, so when we get down to start doing some of our CV2 commands, they become a lot easier because we've set these parameters up here. And so I really like to do that. I'm going to say I want a height of the text of 1.5. Okay, I want a weight, how heavy it is, W-E-I-G-H-T. I want the weight to be 3. Okay, and then I need to give it a color, so I'm going to say my color is going to be equal to, let's make it blue. So I'm going to say 255,0,0, like that for my color. How does that look? I think that's pretty good. Okay, now also we're going to be calculating frames per second, so we need to initialize frames per second to 0, just so the first time through the loop it does not crash out on us. Okay, now is going to come 3 lines that are kind of tedious, 4 lines that are kind of tedious, but we're going to set up our object detector right now. We're going to set up our object detection right now by creating a detector. And so the first thing we need to do is create some base options, and those are going to be that core, right? And that core we imported up here. Okay, that core library, we need to pass it some values. So core dot base options, make sure you get the case right. And now we've got to give it the file name. Okay, and what is the file name? It is equal to model. All right, and we should have set model up here. I hope we did. Yeah, we set model up here, so it's going to know what model is already. And then we need to say use underscore Coral. And the Coral is that Google GPU accelerator for the Raspberry Pi, but I'm sure most of us don't have that, and I don't have it. So since we don't have it, we're not going to use it. So we're going to set that to false. And now how many threads? Num underscore threads is equal to num underscore threads. Okay, and right, we defined num threads up here, I think. Yeah, we defined num threads up here, so it should know what that is. So we got num threads. And now what else do we need to do? Num threads. So that we've done the file model, use Corel false, and num threads. And so that should be it for the base options. Now we got to do the detection options. And those are going to be equal to core, or I'm sorry, this is going to be the processor. And what is the processor? We imported that up here. That's the library that we imported there. So now we're going to have to pass that some parameters. So the processor, okay, it's going to be the processor dot detection options. Okay, detection options. Singular detection, plural options, and make sure that you get your case right. Okay. Now, what are the detection options? Well, max results. And this is how many objects you want to find. Well, if you say 100, you're probably going to be pretty slow. And if you say 1, it's not going to be very interesting because it would only find one thing. So I'm going to say 8, which is probably more than I should, but I'm just going to say that. And we'll see what happens. If we're running really, really slow, we might need to change that. Okay, man, I hope I wasn't in your way on this line here. Let me make sure that you could see this one above. Okay, so base options is core.baseOptions file underscore name is equal to model, comma, use underscore Corel is equal to false. Use Corel is equal to false. And then num underscore threads is equal to num underscore threads. And then we end it there. Okay, so I'm sorry if my head was in the way of that one line of code, but I think you were able to now see it. And so max results is equal to 8, and then score underscore threshold is equal to 0.3, like that, okay? And what does that mean? That means if you want like a score threshold of 0.9, it has to be absolutely positively sure that it's right before it shows you. And the lower the threshold, the more things you're going to find, but the more likely you're going to misidentify something, if that makes sense. Okay, so now we did that. Now we're going to come up to options is equal to vision dot object detector options. Okay, so the first one was processor.detect options. Processor.detect options. This one is vision.object detector options. Okay, do you see that? And this one is going to be a okay, this one is going to be, we're going to pass it base options equal base options. Okay, because what? We already determined base options up here, and this should be base options plural. Okay, base options plural. And then we pass the vision object detector options, we pass it the base options, which we have already set up, and then detection options. Okay, detection options is equal to detection underscore options. Okay, so let's kind of just review this. In this line of code, I set up my base options. Okay, in this line of code, I set up my detection options, and then now I have my overall options is vision.object detector options, and I pass it the base options that we just created, and then I pass it the detection options. All right, and this is basically then one more thing that we have to do to actually create our detector based on all these options being set up. And so our detector our detector itself is going to be vision.object detector, object detector, create from options, and then what? Options. All right, so this could be kind of confusing, but you just got to get this in, and then you see, what does this allow you to do? It allows you to select the model. It allows you to use the Coral if you have one. Okay, it lets you set the number of threads, the number of results that you want, and then what threshold you want for detection. And then it comes together, you build the detector this way, and then you can go in and you can change it as you need it. But I know if you haven't seen this type of thing before, it's a little confusing the first time, but now you got your block of code and you can just use it. Let's try to run this. There's no telling how many errors I made in there, but let's see. Okay, max results, it doesn't like that. Max results, like that. Let's try to run it. I really just like running my code as I go along because, okay, object detector options. So where is that? That is in line 39, object detector options. Okay, so let me look at this and see which one that is. That is line 39, and that is my options is equal to vision. Yes, object, detector options. Hopefully you caught that. Okay, hopefully you caught that. Let's run it again, but you see it's nice to kind of debug your code as you go. Object detector, man, I've got all kinds of errors in here, line 40, and so detector is vision.object detector dot create from options. Man, that looks right. Okay. It doesn't like object detector. Object detector. I hope you guys did not follow along with those mistakes. Hopefully you got it in right. But code like that is very tedious because it's a lot of parameters and a lot of different things. Okay, and so it says that it created the delegate for the CPU. So that's good. That means that we have this thing nominally up and going right now. So I think that is pretty good. So now we're ready to go in and actually do some object detection. So we're going to say while true, when is true, true, true is always true. And then what are we going to do? We're going to read the image. Well, if I want to read it from the webcam, I would just say the return value, which you ignore, and then IM for image, and that is equal to the cam that we set up read. And so this would read from the webcam, or if we want to read from the Raspberry Pi cam, we would do a IM is equal to PyCam2, which we set up .capture .array like that. Okay, and then I'm going to give it an ability if we need to flip it on one of these. So IM is equal to cv2.flip. In case one of these is upside down, we would take the image and we would flip it -1, which will do the correct 180 degrees rotation. Okay, so now I should have an image. And before I go in and do object detection, let's just see if we can grab the image and show it. And so now what I'm going to just do is I'm going to say cv2.im show like that. And then what am I going to show? I'm going to show the camera. And then I'm going to show the image like that. Okay, now what I got to do is if cv2 wait key, and we will wait for 1 millisecond for a key to be pressed, and then if that is equal to the ORD value of Q, okay, so that means if I press the Q button, what do I want to do? If I press the Q button, I want to break out of this. Okay, and now what would I do when I break out? I would want to most certainly cv2.destroy all windows, like that. Open, close. Okay, so now let's just see. Now I've got to decide which camera I want to use. Let's use the Pi camera, and so I'm just going to comment this one out like this. And I think the Pi camera, I'm mounted on that pan tilt bracket, so I think I do need the flip. So let's run this and see what happens. Okay, doesn't have any object capture. What happened there? Okay, so image is equal to PyCam2. It should be underscore and not a dot. Capture array, like that. Let's try it again. Boom, look at that. Okay, so I've got that camera working. That's good. Now let's make sure the other camera works. And so what I'm going to do is I'm going to come up here and I'm going to uncomment out that, and that'll turn on the webcam. And now I'm not going to use the Raspberry Pi camera like that. And then I don't need to flip for the webcam because I think it is up the right way. And let's see what happens there. Okay. Boom, you've got my desktop there. Okay, let's, yeah, that was my desktop. So that's all working. Now the next thing I want to do is we really want to pay attention to the frames per second. And so let's make sure I put the frames per second equals 0 up there. That is very good. Okay, now I need to go ahead and get my start time. If I'm going to do frames per second, I need to say t start is equal to time.time. And so that's just looking, when am I going into the loop? What is the clock time when I'm going into the loop? And then down here at the bottom of the while loop, I'm going to go ahead and say t end is equal to time.time. Okay, so between the start time and the end time is the loop time. So I'm going to say loop time is equal to t end minus t start, like that. So now I have the time through the loop. And then now what would the frames per second be? Well, the frames per second would be equal to 1 divided by the loop time, like that. Okay, but now I want to put a low pass filter on here. And so you guys have seen me do this many times. If you don't understand this, go in and look at my other earlier videos, but I'm going to take 0.9 times the frames per second from the last time around, and then I'm going to add 0.1 times the present one, and that will give me a smooth version of the frames per second, so it's not jumping all over the place. And so I should have frames per second now, and let me just print frames per second just to see what happens. Make sure this works. So let's see what happens. Did not like that. T end is not defined. I must have a typo in there. Kill the program. Okay, T uppercase E. That should fix it. So let's see what happens now. Okay, so it's running and I'm getting not a good frames per second down there. It's better than that, so I must have an error in there somewhere. So let's look. Okay, so we are going to see what I made. I said T end. I see what I've got to do. I've got to go ahead and snag the T start for the next time through the loop. T start is equal to time. And so what I'm doing is I'm saying this is the start of the loop, the step before we go up there. So I think this should work this time. Yeah, so it's getting on up there for frames per second of about 12. And for the webcam and for an image this size, that's about all that I am going to be able to get probably. That is probably about all that I am going to be able to get. I got kind of a busy desk going on here, don't I? Okay. Shouldn't play around with things so much, but just thinking about the next few steps that we're going to be doing. Okay. So let me come in here and quit out of that. Okay, so now I've got frames per second. The printing actually is a slow step, so when you print things, that slows you up. So I'm going to take that out. And then what I'm going to do is I'm just going to come in and put it on the screen. And so before I do the cv2.imshow here, I'm going to put the frames per second on there by saying cv2.put text. Where do I want to put it? I want to put it on the image, and then I want to put what? The string value of the integer value of frames per second, because we don't need a lot of decimal points there. And then I'll close the int, I will close the string, and then I will say append to that, concatenate to that, the labels FPS for frames per second. So that's what I want to put on my image. Where do I want to put it? At the position, which we defined above, and now height, which we defined above, my color, which we defined above, and weight. You see how easy these things get if you define the things above. Let's try it now. Let's try it now. Oh, argument font face. Okay, font face has to be a what? Okay. Oh, did I forget to put position, and I forgot font. Like that. Okay, now let's try it. Did you guys see that font? Okay, boom, 12 frames per second, got my desktop. Okay, that looks really good. So you guys are probably getting tired of me writing this code, like, when do we get to the artificial intelligence part? I'm getting tired of this. Well, I wanted to take you through this in case you're kind of new. I didn't want to lose you, so I'm sort of showing you all the steps here. And if that offends you, I'm sorry. If that offends you, I'm sorry. Okay, so now let's go in and let's actually do the artificial intelligence. So at this point, I have my image, right? At this point, I have my image. But what is the quirky thing about OpenCV? It captures the images in blue, green, red, where OpenCV captures the images in blue, green, red, and TensorFlow wants them in RGB. So what I'm going to do is I'm going to say ImportError is going to be equal to cv2.cvt color. And what do I want to convert? IM, the image, and then how do I want to do it? cv2.color. Okay, cv2.color underscore BGR to RGB. And so this will do the conversion where it will take IM, it will make take you from BGR to RGB and then put it in the file ImRGB. Okay, now I have an RGB image. Now I have to create my tensor image. So the ImTensor, this is the image format that is wanted by TensorFlow. And how do I do that? That is going to be equal to vision, the library that we imported, .tensor image create underscore from underscore array. And then what do we want to create it from? Well, the ImRGB that we just created. Now I've got the tensor image that I can send to the tensor library to do the detection. So now I'm going to get my detections, and those are going to be equal to detector, which we already set up, .detect, and I want to detect on what ImTensor. I hope that even though you don't perfectly understand every detail, I hope it kind of makes sense. So we created ImTensor from ImRGB, which we created from capturing from the camera, and now I should have all the objects detected, and they are kept where? In that data structure detections. Now what I want to do is I want to create an image which is going to be equal to utils.visualize, okay, And I want to do that on what? I want to do that on M, our original image, and then I want to decorate it with detections. Okay, so we've got the detections that we found, and now we're going to pass it those detections, and we are going to pass it the original image, and then it is going to create a decorated image, if that makes sense. It's going to decorate this IM, if I am thinking about this right. Okay, and so then now IM is going to be decorated. It is going to be decorated with these annotations and stuff. Okay, so if I am thinking about this right, I will need you to hold your breath. Ah, wow, Shazam, look at that. Okay, wow, look at that. It is finding lots of stuff. So let's see the stuff that it found. It found a mouse, it found a mouse, it found a mouse, it found a keyboard, it found another keyboard, it found 2 keyboards, 3 keyboards, 4 keyboards. It found the cup over here. But now let's see, it found me as a person. And we're operating at 6 frames a second. That is pretty amazing. Now, I'm tired of all these mice because you see I hit my max of 8 things, so I'm going to get those mouse out of the way. And now what did it find? Now it found the scissors. For a brief moment, it found the scissors. Okay, yeah, it found the scissors. And let's see if I can get one of these keyboards out of the way. Okay, because it still is hitting that limit. So now I've got keyboard, and I've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8. I think I'm still hitting my limit there. So let's see, I'll put this over here. And again, it's seeing too many different things. Let me take that other keyboard out. And let's see if I can find some different stuff. Okay, you see it's finding the cup now. And let's see if it can find this bottle if I put it somewhere. Okay, I think it's trying to find the bottle. Yeah. Okay, do you see that it found the bottle? And let me move this keyboard out of the way. Give me a little more room here. So I've got bottle, mouse, keyboard, keyboard, person. And then I'm going to, man, I'm trying to figure out what to take out of the picture. I got so much cool stuff. Okay, so now you can see it has scissors. Banana. Did you see that? Actually, I had a real banana here. But as I was going through the lesson, getting ready for it, I kind of got hungry and I ate the banana, but I'm surprised that it is finding the peel. But you see, still the problem is it's seeing too many things, so it doesn't get around to banana. Okay, now it's got bottle, banana, person. Okay, and now let's see if it will figure out what this is. Cell phone, banana, cup, scissors, keyboard, and person, operating at 5 frames per second. That is actually pretty darn amazing if you ask me, to be able to get that type of performance out of a Raspberry Pi. So let's see if we can make it a little bit simpler here. So that was 5 frames per second, which is pretty darn good. Let's come up here now and let's switch cameras. So I'm going to turn on the Raspberry Pi camera. I'm going to turn off the webcam, and we're going to run it again and see what happens. That was pretty amazing. Okay, so we've got a person. And now we have a person. Where is this? I need to point this down a little bit. Okay. We have a person. Man, everything is backwards for me. Okay. We have a person with a bottle. We have a person with a bottle. And let's see if we can get this banana. Person with a bottle and a banana. Okay, let's see if we can come here. Man, this camera angle is really quite annoying because it's becoming, okay, a person with scissors and a banana. What could possibly go wrong with a person with a scissor and banana? That is pretty good. Okay, what I'm seeing here is now with the Raspberry Pi camera, we've dropped to about 4 frames per second. So I'm not quite getting the speed that I was getting with the webcam. Let's see if we go to 640 by 360 like that. Okay, and now it's still kind of slow there. It's still kind of slow, but we've got a person with a bottle, and we didn't seem to save that much time by going to a smaller image, but we got a person with a bottle and a banana peel. That is just pretty cool. You know, I'm kind of curious why we're not getting better frames per second on that Raspberry Pi camera. And somehow I have the feeling that somewhere along the way in one of these updates, the Pi camera isn't working as well. But let's say if I turn off the detection stuff, I just want to see what we're getting. So I am not going to do that. I'm not going to do that. I'm not going to do that. And the other things are doing. So I'm not doing the detection stuff now. And so let's see what my frames per second are. Okay, wow, boom, right there up there at 30 frames per second. Let's go back to 1280 by 720. And let's run that and see what kind of FPSs we're getting here. Okay, well, so this is kind of an unexpected result for me. I would think that I should be getting a better frames per second without doing anything off of that camera. So we'll have to play around with that. That just doesn't seem very good. The other thing that we can do is we're going to come in here, and instead of trying to detect 8 results, let's just try to detect 3 results. And let's see if that runs any faster. If we turn that down a little bit. Okay, yeah, that did seem to, but I didn't turn the other things on. So we need to come back in here and we need to turn our detection stuff back on. Okay. Okay, again, seems pretty slow here. We're getting 2 or 3, or probably we'll get about 4 frames per second. I was thinking my microphone is a bottle. That would be a fail. Okay, so we've got a person with a bottle at 4 frames per second, and we'll throw the banana in just for good measure. And bottle. Got to get it where it can see it. Banana, bottle, and person at 4 frames per second. Okay, guys, that is indeed pretty cool. And I have to say that I was impressed with how accurate it was. And I was also impressed that it could do it at the 4 frames per second, because without a GPU, that is really pretty good. Okay, let's talk about the homework assignment for next week. The homework assignment is just for you to show that you have this working, and then show the different things, begin to explore what things the TensorFlow Lite model that we use, this model up here, what things can it detect? You know, you can try different household items, different fruits and vegetables, you know, different things like cups and glasses and knives and forks and scissors, and just different objects, and see this efficient detect light model, what all it will detect. Okay, so that is your homework assignment for next week. But let me kind of show you where we're going here. What do we like about this? And kind of like, this was a little bit of a long lesson, but in one lesson we're to the point of doing object detection now. But this is the kind of problem. We let the library, the utility library, do all the heavy lifting for us. What if we wanted to find something and like track a banana, right? We've got the pan tilt camera there, and with our pan tilt camera, what if we wanted to do something and actually live motion track on the banana? Well, we need to know, not just get an image back that's already done the work for us, but what we need to know is we need to know what is this data structure detections and how do we bust that apart and get the information we need in order to start doing cool and useful stuff. So that's what we're going to do next week. We're going to see if we can bust open this detections and start getting useful information out of it, and then be able to do the text decorations or whatever like we would like to, instead of just doing it like what they have done. And I want to try this again. I want to try just one more time here with the stuff. I kind of like the results that we were getting from the webcam in this particular case a little better. So let's try that again. And I will come back over here. Where are we? Here we are. Okay, so 5 frames per second, it's seeing, now it's just seeing 4 objects. So it's not finding everything because it is just finding 4 objects, but it is, you can see jumping around and seeing the different things. And so I think that is pretty neat. But you see, it gives red boxes, and then it puts the text very small where you can't see it. Well, what if I want green boxes and I only want to track the scissors? Okay, we have to understand that detection data structure. We have to understand that detection data structure in order to be able to do that. Okay, guys, I hope you're having as much fun taking this class as I am making it. It's like been a lot of fun. We've gone through a lot of work on OpenCV, and now we're to the point of really doing some super cool stuff. Hopefully you enjoyed it. If you enjoyed us, give us a thumbs up. Also, it helps us with the old YouTube juice if you'll leave a comment down below. And then if you've not subscribed already, make sure that you subscribe to the channel. When you do, make sure you ring the bell so that you'll get notifications when future lessons drop. And as always, share this video with other people, because the world needs more people doing coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.